welcome back to another episode of SAT Night Live. My name is Jennifer McDevitt and I will be your host tonight. We are going to be covering coordinate geometry on the SAT tonight, so without further ado, let's go ahead and jump into our geometry questions. Coordinate geometry, which if you clarify the difference between plane and coordinate geometry, plane you're usually going to be seeing figures and shapes, whereas coordinate you're looking at figures on the XY coordinate plane. So, our first question tonight, number 9, says, in the system of equations above, c is constant and x and y are variables. For what value of c will the system have no solution? Okay, so it says no solution, but we have 4 solutions, so what does that mean? Well, we want to hone in on the fact that it says no solution. When we're dealing with coordinate geometry, no solution means that we have parallel lines, which look like that. So if we have parallel lines, if you remember from geometry class, that means that they're going to have the same slope. Same slope. Okay, so what is our slope? You might have seen rise over run. You might look at your standard form where you have your y equals mx plus b, where m is your slope. You might have seen your y2 minus y1 over x2 minus x1. But in this situation, we don't see any of those specific things going on, so we want to find the easiest way to solve it and make sure that we're answering the question. So what is the question asking? In our own words, what is it saying? Well, for which value of c will the lines, the 2 lines, have the same slope? There's another form we can look at, the ax plus by equals c. Now you've probably seen that before. So if you take a look at the equations here and here, we see that they're actually already in that form. So the second one, if we look at that, 2x minus 3y equals 8. Well, we have 2x minus 3y equals 8. Well, check this out. Our a is our 2 and our b is our 3. Okay, so what does that mean? Well, if you remember one sneaky little trick, your life will be so much easier. So when we're dealing with this form, we have our negative a over b is another way of putting our slope. So we can go ahead and plug in those numbers. So our a is 2 and our b is negative 3. So that means we're going to have a negative 2 over negative 3. 2 negatives equals a positive. So that means that our slope of that second line is actually positive 2 over 3. All right, so this is our slope. Okay, and if we look at our answer choices, none of them say 2 over 3, so we're not quite done yet, and we need to figure out, okay, I've got the slope of that second line. I want the slope of the first line to be the same as the slope of the second line because that shows that they're parallel, and that means that there's no solution, so that would give us the answer to this question. All right, so cx minus 5y equals 6. Let's write that down again so we have it where we're working. Okay, so again, it's in the form that we need. Our c is actually a, and our negative 5 is b. Pay attention to those negatives. Be careful. So in this case, our negative a over b is going to be negative c over negative 5. And with that negative and negative, that means it's also going to be positive, just like the last one. So this one is positive c over 5. Okay, so I've got 2 slopes. They need to equal each other. What do I need to do? Well, you can set them up and cross multiply. Put them side by side and see what happens. So if we look down here, we have c over 5 equals 2 over 3. So we want to cross multiply, like so. And we're going to end up with 10 over 3. 10 over 3. And check it out, that is one of our answer choices. Choice D, 10 over 3. So what does this all mean? This means that when c equals 10 over 3, the slopes for the 2 equations are going to be the same, meaning that the lines are going to be parallel. So this is a really complicated, tricky problem to start off with. But you can see that knowing the ax plus by equals c form makes life a lot easier. You could have also set it up by doing y equals mx plus b and solve for slope that way. At the end of the day, you want to use the method that you feel most comfortable with. So if you forgot your ax plus by equals c, you could go with another route. Let's take a look at a slightly easier problem. All right, so number 4. In the figure above, if the figure above is a square, what is the value of z? So we're looking for z. Where is it? We see it is over here. Now, z is the first point that we have, which means it represents our x. And if we look over here, our origin is over there at 0. And if this point is over here, that means that it's going to be negative, right? The x value has to be negative. So already we can get rid of c and d. There's no way it's going to be 1 or 2 because we need a negative value for the x. All right, so we're down to a 50-50 shot. Even if we ran out of time right now, we could just pick one and we have a 50% chance of getting the correct answer. But we have some time, so let's figure out what we can do. Well, on this particular problem, if you look at the little ticks here, we've got them going on here, 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 here. We can actually count. And we can make sure that they're representative of what these numbers stand for by checking one of the points that has the x and y value. So if we look at 2, positive 1, we look at our x, we say, okay, 1, 2, that checks out. That's our x value there. And then if we're looking at our y, our rise, that's 1 tick up. So 2, 1. So we know that we can use the counting of the ticks to figure out where we need to be. So going back to this z point down here, we're going to go over 1, negative 1. And that's it. That's our answer choice because negative 2 is over here and our point is right here. So we don't need to go any farther. So once in a while, our problems aren't so bad and they're pretty easy. And as you can see, this is a number 4. So if you remember on the SAT, there's a rough order of difficulty. So the math problems get a little bit harder as you go on. Let's look at a slightly more challenging question now. So 14, we went from 4 to 14. And you can note that in this presentation tonight, if you see a calculator, that means you would find this problem on the calculator section. So we're like, awesome, I can use my calculator, but not so fast. You might have already noticed in your own practice, or maybe you've taken an official test, a lot of times the calculator questions, you don't really need a calculator. And you're feeling like, why don't they let me use the calculator on the really hard ones? It's mind-boggling, but that's the way that they do it. So let's pretend that there's no calculator, because for this problem, you're actually not going to need one. And the question says, in the figure above, what is the length of AB? So we're trying to find the length of AB. Now we have A over here and B over here, and you might be thinking, oh, distance formula, what was that really long thing? It's like all under this radical with a bunch of squares, and oh, I can't remember. Don't worry, you don't need to use the distance formula for this. What you can do is use what you've got in front of you. So just like the last problem, we see our ticks are going here, and they're clearly labeled now. So we see 1, 2, 3, 4, 5. And we can figure out what points with the coordinates of A and B are. So for A, we have our x is here, which is 1, and our y is up 5. So this is going to be 1, 5. And you can write down your test booklet so you don't lose track. And then we want to find our b. So b, we're over 7, so that's our x is going to be 7, and we are up 1. Okay, so what do we do with that? Well, we can draw a triangle and make this line AB the hypotenuse. How do we do that? Literally connecting the dots. So pardon my little shaky triangle here, I'm not an artist, but now that we've connected the dots, we can figure out what this point over here is by subtracting. So to get our height of this triangle, we want to subtract our y values. So we have 5 and 1, right? 5 here and 1 here. So 5 minus 1 means that the height of this triangle we're drawing is 4. And then we can figure out the base of it. So now we want to get the difference between our x's. So we have points 1 over here and 7 over here. So 7 minus 1 is 6. All right, now this is looking like we might be able to do something non-distance formula related. We've got our height, we've got our base, and we've got the good old Pythagorean theorem. So a squared plus b squared equals c squared. And remember, C is always going to be your hypotenuse, which in this case is the line AB. So we can go ahead and figure this out. We've got 4 squared is 16. We can write this all out. So 4 squared plus 6 squared equals C squared. And then we have 4 squared is 16 plus 6 squared, 36, equals C squared. So 16 plus 36 is going to be 52. And we want the square root of that. So you're thinking maybe, oh, now I can use my calculator. Save yourself some time and take a look at the answer choices. Answer choice D has it as written, the square root of 52. So you don't even have to worry about plugging that into your calculator and figuring out some messy decimal situation. They've left it there. You only have to get to the square root of 52, and you're done. So this is a different way that it allows you to figure out the distance or the length here without using that long, complicated distance formula. So let's try another little bit trickier maybe for some of you. So 24 says, in the figure above, the coordinates for point A are -2, 2, and the coordinates for point B are 4, 8. If line CD not shown is parallel to line AB, what is the slope of CD? So we're looking for the slope of CD. And it's some imaginary line, it's not there, we know nothing about it. What can we do? The question's always going to give you some kind of a hint. There's always something in that question stem that's going to have that piece of advice or information that you need to solve the problem. So if we go back and we're looking, how can we figure out AB, CD? Oh, so it says parallel. And if you remember from the first question, when we have parallel lines, we have the same slope. So literally, all we have to do, there's my E up there, all we have to do is figure out the slope of AB, okay? Well, we've got points. We don't have that AX plus BY situation going on, but we do have 2 sets of points. And they're even marked on here. So A over here is that -2, 2, and B is 4, 8. Okay, what do we do? How do we get the slope with those points? You might have seen that good old y2 minus y1 over x2 minus x1. That's we're gonna use this one. You might have seen it written before as y1 minus y2 over x1 minus x2. It's really okay which one you use as long as you're consistent with which x's and which y's you're putting where. So I'm gonna go with the y2 minus y1. So let's say we have 8 minus 2 for our y's, over, and then we have 4 minus -2 for our x's. Well, that's just going to be 6 over 6, because a negative negative is going to be a positive. 4 minus -2 is 6. And 6 over 6, the numerator and denominator are the same, means it's just going to be 1. And that is our answer, choice C. So not so bad. We just want to make sure that when we're dealing with coordinate geometry, we're using the right formula. We're using the formula that's easiest and quickest for us, and that's going to vary from person to person, especially if you're a little bit shaky on formulas. You might want to go with a different way of approaching a certain problem than your friend might, and that's totally okay. At the end of the day, you want to use the method that works best for you personally. So let's go ahead and try one more problem. And again, these last 2 have been calculator problems, and we haven't needed to use them. So we've got another calculator problem, and let's see if we'll need it. It says, which of the following lines is perpendicular to y equals 2x plus 7? So note that this time we're dealing with perpendicular. That's not parallel, so we're not going to be dealing with the same slope this time. When we have perpendicular lines like that, we're going to be dealing with the negative reciprocal. A negative reciprocal. So what does that mean? Well, if I say, oh, my slope is 4. If my slope of my first line is 4, and I have another line that's perpendicular, the negative reciprocal of 4 is going to be -1 over 4, right? Because 4 is just the same as saying 4 over 1. So we're just flipping the numerator and denominator and making it negative. So going back to this first question, we want to find the slope of the first line. It's already in our y equals mx plus b form because it says y equals 2x plus 7. So our slope, in this case, is going to be 2. So our slope is 2. And we're just looking for the slope of the line that's perpendicular. So the negative reciprocal is going to be negative 1 over 2. And looking at our answer choices, guess what? Easy peasy, there's only one answer choice that has the slope where our m is of negative 2, and that's answer choice C. So we're done. And we didn't have to use our calculator. We didn't have to go through any crazy long process. We don't have to worry about what the y-intercept is or all these other things. We literally just had to find the slope of one line and get its negative reciprocal, and we were done. And you'll often see on the SAT that there are little tricks and ways that you don't have to work the entire problem. So always be on the lookout. Let your answer choices help you and guide you in the right direction so you don't waste any time on a simple problem where you could spend that time on one of those really long, complicated problems at the end if you are trying to get all of those questions. And again, it's going to be within your personal order of difficulty, which questions to skip, which to not skip. But as you've seen tonight, coordinate geometry, though, it might be a little bit intimidating because you haven't done it in a few years. Maybe you took it freshman year and it's a little bit fuzzy. It's not so bad. So just studying your formulas, doing some practice problems, and really letting the answers help you and finding ways to take the scariness out of geometry is going to help you go a long way. All right, so that's it for today. I thank you all for tuning in to tonight's episode of SAT Night Live. I will be back again next week, and I look forward to seeing everyone. Have a good night.